Make sure you've done number 21 on your own first before watching the video. This is a percent change problem. We have to make sure in our calculations and the equations we build that we're representing those percent changes appropriately, and we do not want to represent these as percent of problems. So let's begin with the first statement. The number A is 55% less than the number B. Let's translate this using a formula that I like to use for percent change. It looks something like this. When you want to apply a percent change to some value, that initial value that you're applying the percent change to is here. It's this value n. So this is our original value. And then we multiply it by a factor of 1 plus or minus r, where r is going to be the percent change as a decimal. And it's plus if it's a percent increase, and it's minus if it's a percent decrease. So let's apply this rule to this first sentence to build an equation in terms of a and b that will be helpful to help us eventually find the actual value of a. So the number a, so let's write this, a, is, we translate that as equals, 55% less than the number b. So this can be translated as b decreased by 55%. So b would therefore be the original or the starting value. And we're going to multiply it by 1 minus 0.55. The minus because we are decreasing, and then 0.55 because we got to take our 55% and turn it into the decimal form in order to use it in this equation. So either we divide it by 100, or equivalently, we take the decimal point and we move it 2 places to the left. Either way, we get 0.55. So this is the same thing as a equals b times 0.45, or a is equal to 0.45b. So let's hold that for a minute. Let's look at the next statement. The number b is 320% greater than 160. So b is equals 320% greater. Be very careful. It's possible when you did this problem, you did something like this. 3.20 times 160. I'll talk about what that is and why that's wrong in a minute, but that's not what we're going to do here, because this is 320% greater than. It's a 320% increase on 160. So 160 is our initial value that we're increasing by 320, 320%. So now we're going to multiply it by this factor, 1 plus, because we're increasing, it's greater than, 320% as a decimal. And so even though it's bigger than 100, we can still apply the rules here. I either divide by 100 or you move the decimal point over 2 places to the left. Either way, we get 3.20. So now we're going to get, if I combine this and rearrange, 4.20 times 160. And not 3.20, but 4.20. So I'll come back to what's going on here in a minute, why 3.2 is wrong, or what the problem would have to say in order for you to use 3.2. Let's finish this problem, right? Because we can now find the value of b. Pull up my calculator here. So 4.2 times 160. So b is 672. We can take that result, plug it in here, and we'll be able to find a. So a is 0.45 times 672. 302.4. So a would be 302.4. They didn't tell us to round or anything, so we're just going to enter this result directly in, 302.4, into the box, and that's the answer. When would 3.20 times 160 have made sense? That would have made sense if the wording of the problem were this. The number b is 320% of 160. When you see percent problems involving of, that is just going to be taking the percent, so as a decimal, in this case 3.2, and multiplying it by the original number. So you're not doing the 1 plus here. You're just doing 3.2 times 160. The of you can think of as basically just translating into multiply. But as soon as we see anything like greater than, more than, less than, increased by, decreased by, anything that shows a change by a certain percent, we have to use this instead. Another way to think about this, these are kind of two sides of the same coin. If something is 320% greater than 160, we can think of that as, taking 160, which is 100% of itself, and adding 320% of itself to the 100% of itself, right, to get 420% of itself. So you could also think of like this equation we got here as 420% of 160. Ultimately, 420% of 160 is the exact same thing thing as 320% greater than 160. So even though I like to keep separate percent of problems and percent change problems, because I don't typically like to mix them, it can get confusing. When do I multiply by this versus that? So I do like to just say percent of problems you handle by multiplying the percent by the number. Percent change problems, you use this formula. They really are the same thing. They're two sides of the same coin. You can actually interchange between them whenever you'd like. So, if that helps you understand the difference between these, that's great. Otherwise, just stick with percent of on this side, percent change on the other, and that keeps things simple. Either way, the answer to this one is 302.4.